Question 1. Air is pumped into a spherical balloon with its surface area increasing at the rate of 100 pi cm squared per second. Find the rate at which the radius is increasing when the radius is 10 cm. If we let S be the surface area of the spherical balloon, we are given ds over dt as 100 pi cm square per second. And when radius equal to 10 cm, we are going to find the rate of the radius increasing with time. First, we write down the equations for the surface area of sphere. Being S equal 4 pi r squared. We take the derivative of the surface area with respect to time. We get 4 pi and we differentiate r squared with respect to t, and we have 4 pi differentiate r squared is 2r dr over dt. So we have 8 pi r dr over dt. We know that ds over dt is given as 100 pi cm squared per second. So we equate 8 pi r dr over dt equal 100 pi. And this gives us dr over dt equal 100 pi divided by 8 pi r. So when r equal 10 cm, dr dt will be 100 pi over 8 pi r, where r is 10 cm. So we have 100 pi over 80 pi, which is 1.25 cm per second. Question 2. Air is pumped into a spherical balloon with its surface area increasing at the rate of 100 pi cm squared per second. Find the rate at which the radius is increasing when the area is 100 pi cm squared. So we are given the rate at which the surface is increasing is 100 pi cm squared per second. When the area is 100 pi cm squared, we are going to find dr over dt being the rate at which the radius is increasing. We know that surface area of sphere has a formula S equal 4 pi r squared. So when the surface area is 100 pi cm squared, we can equate it as 4 pi r squared. And so r squared equal 100 pi divided by 4 pi, which is 25. And so r equal square root of 25 equal 5 cm. Now we take the derivative of surface area ds with respect to time equal 4 pi dr squared over dt, which is 4 pi differentiate r squared is 2r dr over dt equal 8 pi r dr over dt. And we know that ds over dt is given as 100 pi cm squared per second. And so we can find dr over dt equal 100 pi over 8 pi r. And now when r equal 5 cm, we have dr over dt when r equal to 5 cm being 100 pi over 8 pi r when r equal to 5 cm. So this is 100 pi divided by 40 pi, which is 2.5. dr by dt is cm per second. Question 3. Air is pumped into a spherical balloon with its surface area increasing at the rate of 100 pi cm squared per second. Find the rate at which the radius is increasing when the volume is 36 pi cm cubed. So we are given ds over dt as 100 pi cm squared per second when volume is 36 pi cm cubed. Find dr over dt. We know that volume of sphere has the formula 4 pi r cubed over 3, and it is 36 pi, and so r cubed equal 36 pi over 4 pi over 3, which is 27. This means that r equal cube root of 27, which is 3 cm. And surface area of sphere has the formula S equal 4 pi r squared. And so we take the derivative of surface area with respect to time, we get 4 pi dr squared over dt, which is 4 pi 2r dr over dt equal 8 pi r dr over dt. And so we have dr over dt being ds over dt divided by 8 pi r, which is ds over dt is given as 100 pi. So it's 100 pi over 8 pi r. Now when r equal 3 cm, we have dr over dt being 100 pi over 8 pi r, where r is 3 cm. And this is 100 over 24, which is 4.17 cm per second. D being the rate of radius increasing with time when r is 3 cm. And when r is 3 cm, the volume is 36 pi.
Question 4. Air is pumped into a spherical balloon with its surface area increasing at the rate of 100 pi cm squared per second. Find the rate at which the radius is increasing when t equal 2 seconds, given that the initial surface area is 30 pi cm squared. So we are given the rate of increasing of surface area with respect to time being 100 pi cm square per second, and initial surface area equal 30 pi cm squared. Find rate of increasing of radius when t equal 2 seconds. First, we solve for the surface areas when t equal 2 seconds equal initial surface area plus rate of increasing of the surface area multiplied by delta t of 2 seconds, which is 30 pi plus 100 pi cm squared per second multiplied by 2 seconds, which is 230 pi cm squared. And we know that the surface area has the formula 4 pi r squared, and we equate it with 230 pi, which means that r squared equal 230 pi divided by 4 pi, which is r equal square root of 230 over 4, which is approximately 7.58 cm. Now we take the derivative of surface area with respect to time, being 4 pi dr squared over dt, which is 4 pi differentiate r squared is 2r dr over dt equal 8 pi r dr over dt, which means that dr over dt equal ds over dt divided by 8 pi r, which is dr over dt is 100 pi cm squared per second, so it's divided by 8 pi r. So when r equal approximately 7.58 cm, we have dr over dt equal 100 pi over 8 pi, and r is 7.58, which is approximately 1.65 cm per second. So when t equal 2 seconds, the surface areas becomes 230 pi cm squared, and the radius is now approximately 7.58 cm. and the rate of increasing of radius dr over dt is approximately 1.65 cm per second.
Thank you for watching. If you like this video, please press like, subscribe, and turn on all notifications. Thank you.